Let's solve systems of linear equations by elimination. So just to go over these steps, step 1, you're going to want to multiply, if necessary, one or both equations by a constant, so that at least one pair of like terms has the opposite coefficients. So for example, if you see a 3x, you need to get a negative 3x. Or say, for instance, you have a negative 11y, you want the other one to be a positive 11y. Step 2, you're going to add, erase the subtract, just add the equations to eliminate one of the variables. You're going to solve the resulting equation for the remaining variable. Step 4, you'll substitute the value that you found. Substitute the value from step 3 into one of the original equations. And it doesn't matter which one, it's just a matter of choice. And then you solve. You always write your solution as an ordered pair. Remember that the first value is always x and the second one is y. Step 6, you should always check your solution in both equations. Sometimes what happens is you check in only one, and then when you're checking the other one, you notice that it is incorrect. So if it doesn't work in both, then it is not the correct solution. So let's solve the system by elimination. Negative 6x plus 5y equals 25, and negative 2x minus 4y equals 14. So in this case, which do we want to eliminate first, the x's or the y's? Well, the x's are nicer in this case because 6x, I can make the 2x into the 6x. What we want is, since we already have a negative 6x, what we want is a positive 6x. And so in eliminating the x's in this case, I only have to multiply one of the equations. If you happen to choose the y's instead, you could do that. But notice that you're going to have to multiply both the top and the bottom in order for the y's to disappear. So the x's in this case are the nicer ones. So we just have to manipulate one. So we're going to multiply equation 2. Okay, so this equation, we want to make that a negative 6. So in order to do that, we multiply by negative 3. So multiply equation 2 by negative 3 so we can eliminate the variable x. So let's try that on this side. Make sure that you distribute to every single term. So this becomes 6x plus 12y equals 14 times negative 3 is negative 42. You can always do it on the side if you can't do that in your head. Totally fine. Then let's just rewrite the top equation, equation 1. So that's negative 6x plus 5y equals 25. Now if we add them together, our x's will cancel out. So 5y plus 12y, well, that is 17y. Then 25 minus 42. When you do that on the side, make sure you write the bigger number on top and then subtract. I know it's going to be negative at the end, so to help myself out, I write it there. And we notice that it's negative 17. Divide by 17, we get y equals negative 1. So what we did, just to show you, we added the equations together, and then we solved for the remaining variable, our y value. So we're going to substitute this negative 1 into one of the original equations to solve for the other variable. So we're going to substitute. Let's go ahead and choose this one here. It's up to you. It's a matter of choice. You could always plug it into here if you want to, the one that you changed. You could plug it into this top one or this one. I tend to choose the one that has the smallest numbers. That's just my personal preference, just so I'm less apt to make mistakes. So let's go ahead and plug this in. We know y is negative 1. So negative 2x minus 4 times negative 1 equals 14. Then we solve for x. So negative 2x plus 4 equals 14. subtract 4 from both sides. We have negative 2x equals 10 divided by negative 2, or x equals negative 5. So immediately we can write that as an ordered pair. Remember that the x's get written first, so negative 5, and we have negative 1. So what we want to go ahead and do is to check our solution to make sure it is correct. So let's check it down here at the bottom. So to check it, we check both equations. And so let's do the first one initially. So we have negative 6 times negative 5 plus 5 times negative 1. Does that equal 25? So again, I just plugged in the x into here, into where the x is, and the y into where the y is, and I want to know, is it going to equal 25? If it's true, then it will. So this is positive 30 minus 5. Does that equal 25? Yes, 25 equals 25, so that checks out pretty good. Let's try out the other one. So we're going to plug in negative 2 times our x value of negative 5 minus 4 times our y of negative 1. Does that equal 14? So this is 10 plus 4 equals 14. And 14 does, in fact, equal 14. So that is true. So I want you to go ahead and try these examples here. Now, number 4, to help you out, you can choose whichever variable you want. Either one works, either the x's or the y's, because we only have to multiply one equation. We could make the x's to be a 6x and a negative 6x, or we could make the y to be a 3y and a negative 3y. So you decide. Pause the video and try it out. So if you tried out this example, you would, what I did is I multiplied the top by negative 3. So I already had a 3y, so I wanted to make it a negative 3y. So multiply by negative 3, distribute to each term. So notice I get negative 9x minus 3y equals negative 33. Then I rewrite equation 2 below it. Then the 3 y's cancel, and so I get negative 3x equals negative 9. Then I divide both sides by negative 3, so x equals a positive 3. Once I figure out my x value, I plug it back in to one of the equations. In this case, I plugged it into equation 2. So I plugged in 3, my x is 3 into there. And so 6 times 3 is 18, plus 3y equals 24. Then I subtracted 18. So then I get 3y equals 6, or y equals 2. Then I did a check to make sure it was correct, and I know for a fact that it did. So this is 3, 2. So go ahead and try these last two examples, number 5 and 6 on this side. The answers are at the bottom to kind of help you out to see if you got it correct. But pause the video, and then I'll have the answer for you when you return. So in this example, you see 4x minus 5y equals negative 19, and negative x minus 2y equals 8. So I have 5 and 2 and 4 and 1. So the x's are actually the nice ones to eliminate here. We have a 4x, and so this is a negative x. So what we want is this needs to be a negative 4x. Because remember, 4x minus 4x, that's going to eliminate and make that 0. So that's what we tried to do to equation 2. So I multiplied by 4. Then I got negative 4x. 4 times negative 2 is negative 8y. 4 times 8 is 32. Then I add them together. Notice my x's cancel out. Negative 5y minus 8y is negative 13y. Negative 19 plus 32 is a positive 13. Then divide by negative 13 to both sides, and you get y equals negative 1. Once you figure out that value, then you plug it back into one of the equations. So I plugged it into equation 2. And then I got x equals negative 6. I see the answer in the bottom down here, so it's okay, but you should do a check. Go ahead and try example 6, and then in the next video I'll go over that, and then I'll also start on multiplying with both equations. Thanks for watching.